This Week in Startups is brought to you by GoToMeeting. Meeting is believing. Visit gotomeeting.com, click the Try It Free button, and sign up for a 30-day trial. And Wistia. Take control of your video marketing with powerful tools and analytics built specifically for business. Go to wistia.com/twist to get your free Wistia account today. Today's episode, filmed at the 2016 Launch Festival, features Will Marshall of space startup Planet Labs.
So we've actually now launched over 100 of these satellites. It's the largest fleet of Earth imaging satellites in history by more than 10x. And with these satellites, as I said, our goal is to image every single point on the Earth's surface every day.
And DeSimone of 3D printing pioneer Carbon3D.
Our plan is to convert 3D printing from the hype and the typical prototyping into starting with real materials into real parts and grow this new category of 3D manufacturing.
Next up, we're going to go to space. So we've been through the money and startups, education, and now we're going to space. Will Marshall is the founder of Planet Labs. Will, come on out. Come on out, brother. Join me. And here it is. We have something under here. Good to see you, brother.
Hey, man.
Thanks for coming so much. Have a seat.
Cheers.
Cheers, yeah. Are we going to show them what's under here, or are we going to do the deck first? What do you think?
Whatever you want. What's do you prefer?
God.
Oh, I forgot the clicker.
Oh, clicker. Here it is. Thanks, Tyler. Nice catch. Wow. All right, here we go. Well, let's show them what's under here.
Okay, yeah. So basically, we at Planet Labs build and launch these ultra-compact little satellites. I've actually got one here. Not much of a reveal since the guy already came on stage with it. So basically, we build and launch these little satellites. There's a real scale model of it. It's not like a shrunken version. They are 10 by 10 by 30 centimeters. And we launch them, by making them so compact, we can launch them in large numbers. And by launching them in large numbers, we can do different sorts of capabilities that no one has ever done in space before. In particular, our aim is to do Earth imaging. So mainly in here is a telescope looking down, and we're taking images of the Earth. By launching about 150 of these, we can image every point on the Earth's surface every day. Yeah, don't drop it. It's really expensive.
What do they cost?
I'm not going to tell you that. That's about the only thing I'm not going to tell you.
Oh, okay. But they're not cheap.
Well, the launch costs are very expensive.
I heard.
But by making them smaller, we definitely bring that considerably down.
Hey, can we watch the video of you launching them? How many of these?
Yeah.
Launched?
Let's show some of the slides.
Yeah,
I can help explain. So, can we have the slides up?
Yep. Give me a second.
Let's see how this
solar panel. Oh, here we go.
Oh.
Whoa.
Okay, well, this is jumping right to it. This is a video of 2 of our satellites being deployed from the International Space Station. You get a sense of how small our satellites are compared with the Earth.
Partial
Sputnik, it means little satellite, the Russian cosmonaut is saying in the background. So as they fly over the Earth, then we orientate them in order to point them down to take images of the ground, and this is the kind of land they fly over. So we've actually now launched over 100 of these satellites. It's the largest fleet of Earth imaging satellites in history by more than 10x. And with these satellites, as I said, our goal is to image every single point on the Earth's surface every day. And I've actually got in here, this is the kind of land that they fly over. So our mission, image the whole Earth every single day. Basically, to date, satellite imagery has been taken every few years. The satellite imagery you find online is 3 to 5 years old. By taking an image snapshot of the whole Earth every single day, we can see changes as they happen. That's useful for a wide variety of use cases. For example, a lot of humanitarian ones like tracking deforestation, tracking the ice caps melting, helping people in times of disaster response. So when there was the Nepalese earthquake last year, we open sourced all of our data of Nepal. People were able to find where villages were affected that no one could see before. And then there's a bunch of commercial cases for this data too, ranging from people to having up-to-date maps on their consumer mapping platforms, through to finance, where our data can help people to predict, for example, crop yields, because we can track the crop yield around the whole world every day, or ships into and out of ports, or output from mines and things like that. So there's a wide variety of sort of use cases like that. We have a scanning system compared with the normal system and basically we're putting 150 of these into a single plane. Each one takes a strip of images. Each one of these guys takes a strip of images down. And then by the time the next one comes around, the Earth is rotated just a little bit underneath this plane so that it takes a strip next to the previous one. We call it a line scanner for the planet. We've launched 113 of these on 10 different launch vehicles. And this is the kind of imagery we get. We can actually see ourselves here. And if you zoom in, you can see every boat on the water. This is not super high resolution. We're able to see a tree and a car, but not read a number plate or see a person.
You sure I can't see the number plate or the person?
You're sure. And by the way, no one can read the number plate from space. That's just...
Is it because of the angle or is it because of the fidelity?
It's because space is really far away. Sorry, roughly speaking.
He knows the interviewer, obviously.
We're taking a picture from here to LA with this thing. It's 500 kilometers away, and this is what we're seeing, right?
Okay, so when they are looking at Osama bin Laden's compound,
yes,
they know there's a guy walking around.
Yeah, perhaps.
That's
maybe.
Just about. That's about as far as it goes.
If they happen to have their satellite over at that time, which is very unlikely.
Yeah. Will it ever get to the point where the government or people will be able to identify individuals on a satellite?
I don't think so, no. You could do that with drones, but I don't think you can do that with satellites. Inherently, you're so far away, and it's something we care a lot about personal privacy, which is why we're trying to keep this at a resolution where we can see and count trees, but not identify people or even identify cars and things like that. We think it's much better our goal is to scan the planet and see these big macroscopic changes to help us to take care of the planet.
And what are we seeing here?
This is, we have a near infrared band, and so we can actually tell the crop yield on a pixel by pixel basis. Basically, chlorophyll sticks out like a sore thumb in near infrared, which is one of the channels that we have. We can tell crop yield, which helps farmers to improve their yield. There's a few other examples here which I can show. This is a refugee camp. If I go back and forth, you can see how that is these individual tents in the refugee camp. This is deforestation in Indonesia. This is the last image on Google Earth. Here's our updated image taken a bit later, and you can see these inroads where they're doing deforestation. Here's the Spratly Islands that the Chinese are building out in the ocean.
These are the islands.
These are the islands. These are man-made islands, and we're just seeing them as they're being constructed.
Why are the Chinese making a bunch of islands?
Well, I'm not a politician. I'm not here to explain why they're doing this. The thing is, our data is just neutral in that sense. We take the pictures.
I mean, I understand why Putin would be making them. He's crazy, but the Chinese are making these for a purpose.
I presume it's something to do with expanding territorial waters or something.
These are the ones that they're in dispute with.
Absolutely.
Japan and
There's
other
some
people.
sort of dispute going on.
So they're actually building them up.
Yeah.
You actually know that.
Yes, we get, by helping to, it's like we're helping to provide transparency about what's going on the planet, whether it's related to deforestation or crops or what have you.
How do governments feel about the fact that you as an individual can start a company, raise capital, and put something like this out in the world, which was something that was previously only the domain of nation states? Is that correct? It was only the domain of nation states 20, 30 years ago?
Absolutely, yes. So, I mean, traditionally, space has been the domain of nation states, and, it's been possible with the advances in technology to miniaturize these satellites, and it's become able to be in the realm of private enterprise. We are one of the first folks to be doing that, so it's relatively new. Governments are generally very supportive because they get to get information about what's going on in the world as well, and that helps them in many ways. And we're seeing a lot of developing countries interested in our data because they just want to track what's going on in terms of buildings in all the urban areas. They just want to understand and help agricultural yield in their countries. So there's a huge number of positive use cases like that. Here's basically there was a question mark about whether there was a incursion into this village in Iraq, and we took this image a couple of hours.
Yeah, I think there's an incursion.
Yeah, so yes, there's an incursion, and we see construction as it gets built. So basically, we see the changes. We see the changes on the planet, and the general summary is that Tim O'Reilly talks about the global brain. Well, the internet and how it's becoming a bit like a global brain. Well, we think of ourselves as the global sensing system that we need for that global brain. It's the sensing system that enables us to take care of the planet in the broadest way.
Hey everybody, let me take a moment to tell you about GoToMeeting, which I use all week long. Yes, I'm meeting all the new potential incubator companies and looking at their products, and I do it. I've taken my meeting game to the next level with GoToMeeting. It is so easy to use. I recommend it wholeheartedly. I've used it for years. It's so easy to collaborate with clients and colleagues from anywhere. And so, be a meeting MVP no matter where you are. You can use your phone, you can use your tablet, you can use your desktop. It's so easy to get these meetings going because you can just do it with one click. I have it in a Chrome toolbar in my Google Calendar. I put something in my Google Calendar or somebody else puts it in mine. One click, I add a GoToMeeting, and then everybody just clicks on the link and magically everybody's in there. Perfect voice over IP, or they can dial in. It works so well. And one of the little features that I love to use is I will have my executive assistant on the phone with me taking notes. You can also record the call, and we of course do that sometimes if we want to take notes. And there's a little chat room in there, so I can chat with people and take notes, and I give startups my notes, my candid notes on what I think of their companies. So all these great little features. And one thing I love is I always have one or two people who are calling in, they're on the road, they've got noise, they don't know how to mute their phone, they forgot their headset. You, if you're in control of the meeting, can mute the participants. So you ever be on one of those phone calls and somebody's like in a wind tunnel, and you're like, who's doing that? Well, you can just go mute, boom, if you're the conference organizer. It works so beautifully. Those are my little tips for you. Screen sharing and passing it off to other presenters, another wonderful thing. I'll have a meeting with 2 or 3 people, and we'll pass the presentation wand from one to the next. It just works. It's so easy for you to step up your meeting game. So I want you to do this right now. It's time for you to put out your best performance. Go ahead and be the meeting MVP of your next meeting. Just start your 30-day trial at gotomeeting.com. Click the Try It Free button. That's, once again, go to gotomeeting.com and click the Try It Free button. You are going to love it. I use it all the time. It gets my highest rating. I love GoToMeeting. Okay, let's get back to this episode.
When you take one picture a day of everything.
One picture a day.
Is the plan to have 5 ribbons, 10 ribbons, 24 ribbons?
Certainly, ultimately, we can go up. And to date, we haven't got to daily imaging. We're still building up the satellite system. By the end of this year, we should have daily imaging of the planet. We're launching this year over 150 satellites. It's more than all other satellite providers combined. It's more than the rest of the world. Not more than like one other company or one government, but more than the whole rest of the world combined. But our satellites are smaller, so it's easier. But by the end of that, we should be getting into our daily imaging. But yes, ultimately, we could go to even higher cadence.
What about the this is low Earth orbit satellites? Is that
right.
The category? So define for me what the space station is versus, say, yours and everything in between.
Okay. Absolutely. As you saw, we launched some of our satellites from the space station, so they're in about the same orbit altitude as the space station. So our satellites are typically 400 to 500 kilometers, so that's part of low Earth orbit. Low Earth orbit extends up to about 2,000 kilometers above the Earth's surface, which, if you look at the Earth, is just a thin, just a tiny bit above the Earth's surface, just a few millimeters on a normal globe, and then medium Earth orbit is where they put the GPS satellites and other global positioning satellites. And then geostationary orbit is typically, that's the orbit that stays above any one point on the Earth's surface at the same time, all the time. And those are generally communication satellites.
These are going to come down and burn up in the atmosphere.
Correct.
What's the lifespan of these?
We aim our lifespan to be about 2 years.
2 years.
Correct.
So you're going to be in constant refresh mode.
Correct.
Is this only possible because of the work, say, like Elon Musk is doing with these low-cost satellites? Because satellites were very expensive before he got into the game.
I mean,
I'm sorry, rockets.
The rockets.
Yeah.
The rockets actually, Elon is helping by making more availability of rockets, but the launch costs have stayed roughly the same for the last 40 years. But what we're doing is radically changing how much capability you can put per unit kilogram in that rocket, if you like. So that's
therefore
really
the cost comes down.
Yeah, that's where the big change. I mean, our satellites are about 1,000th of the mass of a typical satellite. Right,
wow.
So we've taken 3 zeros off that mass, and therefore you can just change the way the economics of it that way.
If he is able to reuse the rocket, what are the chances of that? And if when do you think that will happen?
Well, he has already demonstrated with SpaceX that they demonstrated a reusable rocket. They landed it back on the pad. They haven't launched it again yet. I think it's possible. I think he's already shown the hardest bit, which is the landing. And I believe them when they say that will reduce the launch costs. And we talk to those guys all the time.
Okay, what about the internet capabilities of low Earth orbit? I know there's
communication satellites?
Communication satellites, because when they're further up, like anybody who's ever been on internet by satellite wants to throw the computer out the window because it's, 800 millisecond latency or something crazy?
It's a big latency.
But these ones get so much closer. My understanding is it covers less area, but it will be much faster, only 100 milliseconds or something?
Yeah, less than that. And in principle, you can use a large constellation of LEO satellites to do global communications. And of course, there are companies trying to do that, including SpaceX, OneWeb, and others. And
how many will it take? Because you're doing
they 100 about of order 1,000 satellites.
1,000 satellites.
Now, but these are big projects, and it's really hard to do these things. And last time people tried to do that, it actually it didn't work out, because what happened was the terrestrial fiber got so much cheaper that it ended up not working out. So there's this big project called it's called Teledesic to do this, and it sort of collapsed under its own weight because the cost of these things is really high.
So you don't buy into it, or do you?
Well, I think you have to think. I think there's a huge business case there in principle, but you have to be careful because the terrestrial communication costs are cheap. Whereas doing the Earth imaging, you can't really do that from the ground. I mean, there's no way you can cover the whole planet every day with drones or something. Like, it's just not possible to get the coverage.
How do you make money?
Well, we can sell our imagery. There's lots of commercial applications. I mentioned a few: agriculture, consumer mapping.
Are people buying it now? They pay a license fee.
People are buying that imagery today, and we think that there's a huge and expanding market. Basically, no one's been able to get access to Earth imaging. It's been the province of big governments and big companies. And by making more of it, we're serving a lot of other people as well.
This sounds like probably a silly question, but for search and rescue, is this going to become something that, when a plane is lost or somebody's lost at sea, is search and rescue going to actually be done by satellite instead of planes eventually?
Absolutely. In fact, when you see these news situations of a missing plane, I mean, this should not ever happen again. I mean, by scanning the Earth every day, you will find every missing plane. Unless it goes straight into the water and then sinks, you can find these planes.
Did they contact you about MH370, or was it too...
Yes, they did. And this was too early for us, and we hadn't really put our satellite. But if that happened again, we should be able to really help. But also other kinds of disasters. I mentioned the earthquake in Nepal and how we had helped out with that. Today there's been an earthquake in Indonesia, 8 on the Richter scale. And so we're already scanning our imagery to see if we can help out with the disaster response there. Not only is it important to have the imagery quickly afterwards, which we can do, it's also important to have the imagery from recently before. So in the Haiti situation, everyone's scrambling to take imagery afterwards, but then they realized that the previous most recent satellite image was taken 5 years ago. And so they didn't have an apples-to-apples comparison of what had happened. What was because of the earthquake and what was because of of just time, and they've added stuff.
Are you going to make this available to developers and founders in the room via API at some point and start doing hackathons and being like, hey, here's all our imaging, go to town?
Totally. In fact, we've already started to have some of those things, and we really encourage everyone that's interested in this. You can go onto our website. It's just planet.com. It's kind of cool.
Yeah, that cost you $1 million.
And you can...
Good domain.
Yeah, it's a pretty good domain. We also have planet.org. And you can sign up there to become a user of our data. It's sort of in beta testing mode at the present time, but you can sign up. And the idea is that there's so many applications of this data. I mean, we've listed hundreds of thousands.
Yeah.
Detecting fires, helping agriculture. There's just zillions of little examples. And so we want everyone to come in and play with that data and help us to create the applications that would extract the relevant data.
Okay, I'm going to go a little off topic here.
Please.
Yuri Milner is funding, I think, the SETI project a bit these days.
Yeah, he also funded us.
Oh, Yuri's your funder. Oh,
yeah.
Wow. So I was about to say, he makes these crazy bets, no offense intended, but I mean, he likes to do some of the stuff. In your opinion, and amongst your peers, are we going to find a signal in our lifetime, in the next 30, 40, 50 years, will we find a signal from alien life, yes or no? Percentage, a specific percentage.
From intelligent life, or will we find alien life? Because those are two distinct things. I think there's a very good chance that we will find life on other planets in our lifetime. It will either be on Mars or Europa, or it will be by looking at the atmospheres of these nearby planets. If you look at the Earth's atmosphere, there's 20% oxygen, and there's no known geological ways of producing that. It's only because of life on the planet. So if you did a simple spectra of all of these planets, these thousands and thousands of planets that we've now found around other star systems, and saw one with an oxygen abundance like ours, you'd be able to go, hey, there's life there.
We would know.
But that's different from then communicating and saying hello to those chaps over there if they're intelligent, and that might take a little bit longer, and it's hard to know when that will happen.
Okay.
I think Yuri is interested in both, by the way.
So let's take the first one. On a percentage basis, what do you think the chances are next 50 years we find
15 years?
50.
50, very high.
90%?
I would say north of 90% of finding life outside of the Earth.
Now, if you can,
and I don't mean on the space station.
Okay, so no trick questions here. All right, so now we get into the gambling.
Yeah.
You like to gamble a little bit?
No, I don't.
I do.
Okay.
All right.
Yeah.
So, on a gambling basis, if you were to, you know what the over/under is?
No,
okay, you're going to set the money line right now.
Okay.
How many years till we're in communication with an alien species?
Communication.
We're talking to them, right? Okay, we're having somehow conversation. So you set the line, number of years, and then I say over/under. We make the bet.
I see. Well, I think it's extraordinarily hard to guess that particular number. If you'd have said the other one, I would have said like 10 years.
Okay, so the other one's 10 years.
It's a stab in the dark, which is why I don't gamble. I mean, it's just stupid.
Okay, for the 10-year one, I think that's like the third time he got me. All right, let's take the 10-year one. We'll take the 10-year bet because everybody can sweat.
On finding life, not finding intelligent life.
Okay, I take the over.
Okay, yeah.
You got the under.
Yeah.
And 10's a push.
Yeah.
What are we betting? How about the satellite company?
How
about I get to control?
How about I'll name a satellite after you if it's after 10 years?
Okay. You name it? Okay, I like that.
That's better than a poke in the eye.
How about we go for...
Really easily.
I tell you what, we'll go for like Omakase lunch. We'll do an Omakase lunch bet. How about that? So that's like $600 a person or something.
Sure.
All right, Omakase bet. I take the over 10, you got the under.
Yeah.
Perfect. And then the final question I want to ask you about the space stuff, because I know you're in the thick of it. What are the chances you think Elon gets to Mars?
At all?
Yeah, just gets to Mars.
I think he'll get there eventually. I think it's the wrong destination.
Explain.
Yes, he
So Elon's pointing in the wrong direction.
Elon just got his head a bit mixed up. He read a lot of sci-fi about Mars, but the obvious place to set up a permanent settlement, which I think is an important thing for humanity to do, because it's always good to have a backup plan, and not because we want to not focus on the Earth. The Earth is the primary focus. I care about focusing on the Earth and helping the planet. But it's always good to have a backup of your hard drive for the same reason it's good to have a backup of the biosphere. we need to do that, but the moon is the obvious location to do it because it has all the resources. I've sent a few probes there. I'm a little bit biased the other way. And we found lots of water on the moon, and there's plenty of all the resources you need to live on the moon.
Okay, so that's a good step one, getting to the moon.
Can I just say, going back to the planet stuff, just wanted to say one thing that, obviously there's a lot of drone companies, there's a lot of underwater submersibles, there's a lot of devices going everywhere, and I think of this as a sort of a global sensing revolution that we're part of here. It's a big phase where we're getting big data about our planet. And why I think that's important is that when you think of any, Buckminster Fuller made this analogy of spaceship Earth and how we are all actually citizens on a spaceship that's hurtling around the sun. And just like any spaceship, you have to take data about what's going on in that spaceship. If you're on a little space station, you need to take data about the CO2 cycle and the oxygen cycle and how is the power systems doing and so forth on a timescale faster than the timescale you need to adjust it to help it. And with this global sensing revolution, I think that we are helping ourselves as astronauts, the 7 billion of us astronauts on this spaceship, to be able to take care of it a little bit better. And that's what I'm most excited about, space being able to help us to become better stewards and custodians of spaceship Earth. I'm really excited about going to the moon and finding aliens and stuff, but I think the bigger priority is going to be on helping us to take care of this beautiful spaceship called the Earth first.
Well, I couldn't have finished this any better. That is the perfect, I think, capping point off for a wonderful discussion. We wish you much success with this, and I know the developers in the audience are all going to rush over to planet.com and start playing with it. We wish you great success in improving our knowledge of this spaceship we're all on. Let's hear it for Will. Fascinating stuff. Thank you so much. You can leave the satellite. I'll keep the satellite.
Sure.
I've always wanted my own satellite. Hey everybody, let me take a moment to tell you about a product I love and use every day. It's video hosting from Wistia, W-I-S-T-I-A, Wistia. It is awesome. And who uses it? MailChimp, Moz, HubSpot, Zendesk, Herman Miller, Sam Adams, and of course, This Week in Startups. They've got 140,000 customers, and they are growing like a weed. Now, why do we use it? Well, if we use a free service like YouTube, we have all YouTube's ads and collaterals and garbage, and it looks terrible, and it's not customizable. So it looks bad, and everything that YouTube does is in service of increasing their metrics, not your metrics. Well, what are your metrics as a business? Well, for me, it's collecting emails. 2, it's having people on my domain, my site, making it look beautiful, not having that ugly thing that comes up at the end of like a YouTube video that shows all the different videos of other people that I don't want to send my users to. I want, when the video ends, for them to watch another episode of This Week in Startups. I can control all of that with Wistia. That's why I use it. And it works perfectly on Facebook and Twitter with the cards, and you can play it natively on those platforms. It's gorgeous. And it'll give you a ton of support. You want to take control of your video. Video is a huge asset, and you want to do it professionally. The analytics program is amazing. You can see on a user-by-user basis how long they're watching, and if they rewound and watch a section twice, all this kind of great stuff. Tons of support, super easy to use, and it's built, a lot of their new tools are built for marketers, so collecting emails and that kind of stuff. And you don't have YouTube or Vimeo doing that kind of stuff. Those platforms have their own goals, which is selling ads and keeping people on their platforms and stealing those users from your platform. Start your 2-week trial for free on Wistia, wistia.com/twist. No credit card is required because they're so confident that you're going to love the service like I do. And you can upload as many videos as you like. Wistia.com/twist, W-I-S-T-I-A, Wistia.com/twist. I love the product. I love the team. And it's been fantastic for us. We got control of our own videos again. And we are now collecting emails every day, dozens of emails every week, hundreds of emails every year, thousands of emails to build our direct relationship. That is, not have an intermediary between it, telling us how we can talk to you, our fans. We have a direct relationship. It's brilliant. I love Wistia. All right, let's get back to this amazing episode. All right, my next guest is Joe DeSimone, and he is the CEO. And are you founder or co-founder? co-founder of Carbon3D. Let's play the video number 4, because the video sort of tells the entire story. So here, tell everybody what they're seeing.
Yeah, so what you're seeing here is a process that we developed. We call it CLIP, Continuous Liquid Interface Production. This was our prototype machine that we talked about on the stages of TED about a year ago now, where the company came out and we unveiled ourselves. But our approach is to actually grow parts. We actually eliminate the repetitive 2D printing over and over again, and we really get into a continuous fabrication. And so traditional 3D printing, I think, is actually a misnomer. It's 2D printing over and over again. And some of the shortcomings of this are the speed. It's typically a slow process. The layers give rise to poor properties. And there haven't been great material properties up to this point. And so this process is 25 to 100 times faster. We eliminate the traditional layers that one sees. And we have amazing materials that actually have the characteristics to allow us to cross the chasm in the classic technology adoption curve.
Let's take a look at some of these parts you have over here. What are we looking at? And these are manufactured. This isn't for a designer to test it and put it in a wind tunnel. This is to actually use in the real world.
That's right. So we believe in the Japanese culture of the 3 realities, having the actual part in the actual place, undergoing the actual circumstance, right? And so what I'm holding here is a door handle made out of a polyurethane, which is a really important material, and it's got the characteristics to be a final part. And we're beginning to place these. We've got cars running around in Germany now with parts like this. Another amazing rigid material. This is a material called cyanide ester. Most people don't know what this is, even in the polymer world, unless you go to places like SpaceX and NASA or Boeing. This is a material that's got a use temperature about 400 degrees Fahrenheit. And that's an air duct for a NASCAR material, a NASCAR application. And then this material here is an incredible elastomer. And so, if you look at all the different types of 3D printed materials that are out there, nobody has a great elastomer at all. And so we're going to be making sneakers out of this, and this has all the energy recovery that you need for a great elastomeric shoe. And what's also cool is we can tune the properties to be high damping. And so there's applications for the inner ear and hearing aids, all the way to sneakers with this kind of capability.
And as part of this, you've actually started working with BMW. Let's pull up a clip from the part being printed. I think it's video number 1 for my team. What is the partnership with BMW, and are we going to eventually have cars printed by 3D printers?
So we believe it's going to start with components for cars for sure, and the opportunity for really taking advantage of advanced designs. Right now, everything that we have our engineers design are also designed to be manufactured, right? So we send all these students to design rule classes and engineers, and these are all the rules you have to follow for things you can't do. Right? So the biggest opportunity for 3D is complexity becomes free. So being able to make really complex parts. We have an example right now of application in a 5-port valve, where the ability to take a very complicated device and typically made out of 12 parts that would be used in an electric vehicle for pushing coolant around, but to be able to design a much more complicated part out of 1 part, so there's no leaks, you actually can get better applications and service, and do that out of a real material. And so this is how we grow parts. This is an example of a part for BMW. This was just the beginning. A lot of these companies realize the potential for digital manufacturing, the ability to watermark every part, the ability to track it in the field, and really to think about revolutionizing their inventory and how they can control their inventory and tie all this into their ERP system.
And so what about human parts? We had a 3D printed heart here 2 years ago, or components for that.
Yep.
Are you going to be working in that field, and will that sort of pool of resin turn into eventually some human organic material?
Yeah, so bioprinting is almost a different class of printing. So sure. Our life sciences business is probably going to be the biggest part of the company. We're doing a lot. We had a big announcement with J&J in surgical tools. And so designing tools that are real materials that can be sterilized and be used in real medical applications. Huge opportunity in orthodontic applications. And be able to, you think about Invisalign, those are 3D printed devices. And we can make amazing new approaches with this, having the real material. Typically in 3D printing for orthodontics, they make a replica of your teeth, but the actual retainer is made not in a 3D printer, but it's made by thermoforming a 3D printed replica of your teeth. But we have the material properties to actually make the retainers directly, and we're making masks for that fit the face. We're working in orthotic devices for your feet. Anything where there's an N of 1 that's personalized for you is really an important part of where we're going, and this ability to digitally manufacture or mass customize anything is now possible.
What about 3D printed homes? I've seen some videos from China of people pouring cement with what looks like a 3D printer. I think it's probably a little generous to call it 3D printing, but eventually, between nanotechnology and 3D printing, are we going to have pools of resin that would be as big as this stage, and will you just pull up a house?
So actually, I don't think it's going to go that way.
Okay.
I think we're talking about real parts.
Because that would be pretty cool.
It's pretty cool, but that cement example you talked about, there used to be people that did that,
right.
And it's not that sophisticated to now have a robot do that.
Right.
What I'm talking about is really complicated parts that would be used in advanced consumer electronics, advanced automotion, really huge opportunities in satellites and drones out of real materials that have the properties to be lightweight, high-strength materials that can impart characteristics to real important goods. And so our plan is to convert 3D printing from the hype and the typical prototyping into starting with real materials into real parts and grow this new category of 3D manufacturing.
How do you guys make money? Or can a consumer buy one of these? Eventually, will we all have these in our homes? Is that the ultimate vision? Or is this going to be, there'll be factories of these things in, someplace in the middle of America building parts at Amazon on demand that'll be flown to us by drones?
It's the latter by far. So we are right now, so we just did a release of our product. So we have an amazing product, we call it M1. It's in 4 service bureaus we announced this past week. We had the partnership with BMW and Ford and a few other places. We're rolling that product out now. This is available as a subscription agreement. So it's kind of like a SaaS model for hardware. We also have set up a sort of an app store for resins. One of the key things right now is that 3D printing is really built off a lot of 2D printing ideas, and people have been keeping the price of the resin, I think, artificially high. There needs to be truth in pricing on the resins, and part of that is to create a dynamic marketplace. And so having sort of a developer community for resins, an app store for resins is the direction we're going. And so we have the subscription model on the machines. They're being placed mostly at service bureaus so the masses have access to them, but also at large industrials. And then we sell resins. And then in the medical space, we have additional partnerships that will allow us to really work closely with those companies and participate in their business directly. And so it's really focused on the industrial side of it. We have about 130 people located in Redwood City. It's an amazing group of people. This is as much a data story as it is a material story or the machine story. And let me tell you a moment about that. So right now, the ability to watermark every part that comes out of the printer in a factory so that you can tie all the born-on data. How was the machine configured? The humidity, the temperature, the forces while it builds. This machine that we have has over 25 different sensors. It's streaming over 80 million data points per week per printer back to our servers at AWS. All that data is allowing us to build these parts, and the more people that use the printer, we learn. This has got classic network effects, and we believe in a future fabricated with light, where the understanding how to make complex things using light is a data-centric opportunity if you have the process and the materials.
So if this was, in every Honda Civic or whatever car, version 1, the first car off the line would have version 1, and maybe by version 100, some artificial intelligence would say, you know what, if we tweak this, it'll be a little more efficient.
Absolutely.
And then one of them gets in a car accident or this cracks and a service person sees it cracks.
Yeah.
And they can go back and say, that was number 3,722. And the problem was the humidity or this percentage.
You're spot on. You're spot on. In fact, it goes more than that. When you actually look at this, it could be that the fourth thread actually was a thing that failed, because we have the region by region specific data on how it was fabricated. This also really helps with counterfeit. A lot of our consumer electronics, phone companies, people building really important devices are really concerned about authentic devices and the authentic brands. And so be able to give people the ability for protecting their business. The watermark could be covert or overt. And we're only maybe a terahertz reader could read it. No, people couldn't read it. So the opportunity of encoding information directly on the part and then tying it to your special preferences and how you want your shoes to fit, how your things for your ears, your eyeglasses, all sorts of things. The opportunity of building a special relationship with consumers with their major brands is a huge opportunity.
I mean, you could see this in, counterfeit parts are kind of not that big of a deal for consumers when using headphones or, it's a counterfeit phone or some accessory. But when you start talking about airplanes or cars, there's a big counterfeit problem with airplane parts outside of the United States where people regularly change engine parts with counterfeit parts that are 10% of the price.
Yeah, well, at 10% of the price and maybe 10% of the performance.
Right.
So this becomes a huge societal critical safety issue, especially in medical devices. And when you think about personalization, if unfortunately you need a stent, and you actually want a stent that's designed for your own anatomy. And with imaging and tied with 3D printing with real parts, you could have a stent made while you're on the cath table, designed for your own anatomy. And this is where this field's going.
I have a big heart, so that'd probably be necessary. But
we'll have a bigger printer.
How long have you been in this business, the 3D printing world and the material science world?
So I've been a faculty member at the University of North Carolina for 25 years. I've been a material scientist and have launched several companies, including a biodegradable stent company. We have about 100,000 people with our stents in them.
When did you first see a 3D printer? When was the first one sort of played with in the laboratory?
Yeah, it was about 15 years ago in orthodontic applications.
When you saw that, where did you think this was all going vis-a-vis 15 years from now? Could you have predicted where you are today with carbon?
Back then I didn't. Back then I was really impressed, like I think a lot of people have been with 3D printing. The challenge is the technology hasn't changed in 25 years. It's still 2D printing over and over again, and it's actually slow. And for me, what I was, and most people are printing toys, right? Or doing gimmicky things.
Christmas ornaments. I
was really interested in changing the way manufacturing has been. And in order to do that, we have to have real parts out of real materials, and we have to go a lot faster. And so there's a category of 3D manufacturing that's just non-existent. And so we saw it from the beginning that if we could do this, if we could assemble the right team, that's why we came out to Silicon Valley. We've got an amazing team we've got about 20 people from Tesla. We got a bunch of ex-Google folks. We got a bunch of ex-Apple folks. We got a third software, a third hardware, and a third materials, all trying to revolutionize manufacturing.
Where do you think this will be in 15 years? You sped up those videos 7x so we get to see it. Will you hit that speed in 15 years, or will you be faster than that?
So we've demonstrated to ourselves that we can run this really fast. So fast that it's 2,000 millimeters an hour we've done. And my engineering team goes crazy for me to say those numbers out loud. But we've done things that fast. The parts get really, really hot. And what's exciting from my point of view, we can run this so fast, we now have to think about, and it's a chemical engineer in me that's getting excited, we have to think about heat transfer. We have to think about cooling the systems down in order to build our parts. And that's for techie, that's an exciting place to be.
50 years from now. We did 15. Let's talk 50 years from now.
50 years is a great number. If you look at Moore's Law, everyone here knows what Moore's Law is about. All those integrated circuits that are fundamental principle of Moore's Law, they're all made with light. Light is a very powerful chisel. It has driven Moore's Law for the last 50 years to make things in 2 dimensions. And what we're doing now with light is to add a 3rd dimension. And semiconductor manufacturing is a $300 or $400 billion industry. Traditional manufacturing is a $2.1 trillion industry. And I believe that light is going to be a really important chisel to fabricate the products of tomorrow.
You talked about the interlacing, like inside the parts, being not possible on some other machines. Where do you think the strength of these parts is headed? Because obviously nanofibers and some of these things are making incredibly strong parts. Yeah. What, for all of us who don't get to work with the BMWs of the world or the Johnsons & Johnsons, what's going to be possible with these? Are we going to make the space elevator because we have a 3D printed, incredibly interlaced, super powerful cable? How will it affect our lives?
Yeah, you bring up probably the most important point. Today, computation's essentially free. What's going to be free with what we're doing is that complexity becomes free. And so it's going to be limited by people's imaginations. And we're now, Alan Mullally's on our board. He was the CEO of Ford and Boeing. And he asked us the other day, how can we train 100,000 engineers to design for clip in our process?
Yeah.
And so we're really trying to get those fundamental design characteristics out in the field because it's really going to be limited by people's imaginations.
To own one of these machines currently, you're talking about what, like tens of thousands of dollars a month for a company?
To own. So we have
to lease it. It'd be tens of thousands a month?
It's $40,000 a year.
That's it?
That's it. It's a 3-year subscription. We have the resin store. We have about a half dozen resins on the resin store.
Okay, so if people are entrepreneurs or hackers, are you going to make this technology available to them specifically at next year's Launch Festival Hackathon and bring the printers and allow us to fuck with it?
Yeah, we absolutely can do that. In fact, this past week, we announced 4 service bureaus, which sort of like the Kinkos of 3D printing, if people remember Kinkos.
Which one are those? Are those like, what are they?
In San Francisco, Sculpteo is...
They're going to have it?
They have it already. They've been printing. We've got TTH and...
If you wanted to print something like this, how do you charge a consumer?
You can go right to the Sculpteo's website and
But what would it cost? Like $100, $500?
I think it's less than that. It depends on what you particular pick. And I think this is probably...
Tens of dollars?
Actually, we're going to be able to make a sneaker with our new machine and the speed we're going to, we'll be able to get that into $30 midsoles. So it really opens up a lot.
What about having different resins or materials in the same structure?
Yeah.
Because this, to me, I can't figure out with my brain how you could take a metal and a resin printer and make a part that fabricates both.
Yeah.
Is that on the roadmap?
It is on the roadmap. We actually have an amazing engineer now prototyping this where we have, instead of the traditional printer where the liquid was coming up underneath the part, we have a whole different design where the liquid comes through the part, and they can be different liquids, and it can be 12 different liquids that cure into amazing materials with very different properties. And so when I talk about a future fabricated with light, I'm talking about that long vision where we have amazing complicated things emerge with amazing performance properties that can do things that people haven't even thought about.
And at that point, we're going to basically pour a cell phone or pour a Terminator.
And maybe bioprinting at that point directly as well.
It's absolutely fascinating. I'm thrilled to have you here, and my mind is super blown. Let's hear it for Joe DeSimone from Carbon3D. It's mind-blowing. Did you meet the Hyperloop guys backstage? Because I think if I put the two of you guys together,
we would love to do that.
There could be something interesting there.
Great. Why don't you hold on to that?
Okay.
All right. Great. Thank you.
This is actually a very good, grip here.